In this video, I will talk about the motion of an electron in a magnetic field. So electron with charge is negative 1.6 times 10 to the minus 19 coulomb is moving with a velocity 2 times 10 to the 5 meter per second along x-axis. So this is an electron here. So that's an electron. This electron is moving along x-axis, and the magnetic field is acting at an angle of 60 degree. So the magnetic field is applied at 60 degree angle with respect to x-axis. Now what we have to find out, what is the magnitude and the direction of the magnetic force acting onto it. As the electron, which is a charged particle, is moving into a magnetic field, there must be a force acting onto it. That force can be calculated by using the Lorentz force, here. So the given parameter, the given values are q, which is given, and the velocity is 2 times 10 to the 5 I. When I say I, what does this mean? That means the direction is along x-axis, okay, and the magnetic field is at an angle. So this problem can be solved in two different ways. Here I'm just using the vector approach. So this magnetic field can be written down into two components, or it can be resolved into two components. So one component will be along x-axis, and this component will be b cosine theta, and there is another component which is b sine theta, and this is along y-axis. So the same thing I have written down here, b cosine theta I vector plus b sine theta j vector. Okay, so b is given, which is 1.5, cosine theta is 60 degree I vector plus b sine theta sine 60 degree j vector. This component here, now if you multiply these two terms together, you will get 0.75, and 1.5 times sine 60 degree will be 1.3 j vector. That means the component of the magnetic field along x-axis is this much, 0.75, and along y-axis the magnetic field is 1.3 j vector. So you might be familiar with the vector product rule, and here I am just revising you one more time. If you multiply I and j vector, and the direction here is always anti-clockwise. If you multiply these two vectors I and j, you will get k vector. If you multiply j and k vector, you will get I vector. Similarly, if you multiply k and I, you will get j vector. But now if you multiply j vector and I vector in an opposite direction, you will get negative k vector. Okay, and if you multiply I vector times I vector, it is 0. And the reason is the way the vector product is defined. If you have two vectors, a cross b vector, the way it is defined is ab sine theta and n vector. Here, if you multiply the same vector I and I, then this angle theta will be 0. So this is the 0. Okay, so what you see here, when I multiply I and j, the third component is always the k vector. That means it is always perpendicular to both I and j vector. So now let's apply the Lorentz force. So the force, the magnetic force, is given by this equation here. Q is given, that is negative 1.6 times 10 to the negative 19. The velocity vector is 2 times 10 to the 5 I vector, which I have written down here, right? And magnetic field is this vector here, 0.75 times 1.3 j vector. So once I have written down all the given values, here I am going to multiply the numbers here. So I multiplied this number with this number. These are the numbers, so you can easily multiply. If I multiply these two numbers, I get this number here. Now I am multiplying I vector times this term here. So 0.75 I vector times I vector. Then 1.3 I vector dot cross j vector. And always you have to write down in the same order. You cannot change the order. Here you see I cross I, then I have I cross j vector. You cannot write down j cross I. Okay, j cross I and I cross j have the opposite direction. So I cross I is 0 and I cross j, you can see here, I cross j is a k vector. You can see from here I cross j would be the k vector. Alright, so now I'm going to multiply this number by this number. This is what I got, and k vector here. So what does the k vector tell you? The k vector tells you that the force is in j direction, and the negative sign here, the negative sign tells you the direction is along negative g axis. So what is here? This means this is x axis, this is y axis, and the force will be into the iPad or into the paper. That is the negative g direction. All right, so that's what it means. And this is the magnitude of the force, which is this Newton here. All right, so now I'm going to talk about an alternative approach for this problem here. And the alternative approach is the magnitude of the force is given by this equation. That's the magnitude, and I have talked about before in the other videos. Q VB sine theta. All the quantities are given. Q is negative 1.6 times 10 to the minus 19. Plug the values of V, and B here is simply 1.5, and sine theta is sine 60 degree. If you do the math, you'll get the magnitude of the force. Finding out the magnitude in this way is pretty straightforward. But now you have to use the right hand rule in order to find out the direction. So how the right hand rule tells you, you have to align your index finger along the direction of velocity and magnetic field, and the middle finger in the direction of the magnetic field. Then your thumb would represent the force direction. So if you use it, then again you can find out the direction is along negative g axis. So this approach works really well when you have to find out the magnitude of the force, but in order to find out the direction, it can be a little bit complicated to use sometimes the right hand rule. It's not hard, but using this approach, you can find out the direction rather very easily. Okay, so I recommend you doing both approach. Okay, if you need to find out the direction magnitude, you use this way, and if you need to find out both magnitude and direction, then use this approach here. So if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.